Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is the last video, part 17 on the chapter of coordinate geometry, where I will discuss about an interesting concept about the area of a rhombus, where the diagonals of the rhombus are along the coordinate axis, and coordinates of two adjacent vertices of the rhombus are given. How do we find then the area of that rhombus? So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma, where I primarily discuss about the key concepts and formulas for problem solving. If you find this video beneficial, then please like it, share it with your friends, and please support me grow my channel by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so we are given a rhombus. We have to find the area of a rhombus where the diagonals of the rhombus will be along the coordinate axis, which means it will be parallel to the coordinate axis. Now we know that the diagonals of a rhombus bisect each other at right angles. Now we will consider two cases where in the first case the diagonals of the rhombus will actually lie on the coordinate axis, which means that definitely the origin O will be the point of intersection of the diagonals of the rhombus. So PQRS is the rhombus, and the vertices or the coordinates of the two adjacent points, adjacent vertices P and Q are given, where the coordinates of point P are x1, y1, and the coordinates of the point Q are x2, y2. So in the first case, obviously, let's say the diagonals PR is lying on the x-axis. This without any loss of generality, I am considering the diagonal PR is lying on the x-axis and the other diagonal QS is lying on the y-axis. So the rhombus will look something like this. So this is point P. This will be point Q. Let's say this will be point. No, this will not be Q. Let's say this is Q. This is R, and this is S. Okay. So the diagonal PR. So the rhombus is PQRS. Even though it is looking like a square, please consider that this to be a rhombus, where the diagonals are PR and QS, and obviously they are intersecting at the origin O. Okay, so the coordinates of the point P is given as x1, y1, x1, y1, and the coordinates of the point Q is given as x2, y2. Now I am considering so P and Q are two adjacent vertices of the rhombus. Now, okay, so how do we find the area of this rhombus? Now we know that the area of the rhombus PQRS is equal to half multiplied by the product of the two diagonals, length of the two diagonals. So it will be half multiplied by PR, the line segment, the diagonal PR, length of the diagonal PR, and QS. This will be the area of the rhombus PQRS. So how do we find the length of the diagonal PR and the diagonal QS? Where we know the coordinates of the point P and Q. So see that from the properties of the rhombus, the PR is the diagonal lying on the x-axis, and QS is the diagonal lying on the y-axis. So obviously, they intersect at they bisect each other at right angles at the origin O. So obviously, the point R, the vertex R, has to be the image of the vertex P along the y-axis. So along the y-axis. So obviously, the coordinates of the point R, of the vertex R, will be minus x1, y1, negative of the abscissa of the point P. R is the image, vertex R is the image of the vertex P in the y-axis. So its coordinates will be the negative of the abscissa of point P and the ordinate of point P. Okay, similarly, what will be the coordinates of the point S, vertex S? Vertex S will be the image of the vertex Q in the x-axis. So its coordinates will be the abscissa will be the same, that is x2, but the ordinate of the vertex S will be the negative of the ordinate of the vertex Q. It will be negative of minus of y2. So we have found the coordinates, even though it was not necessary to find the coordinates of the vertex R and S, but still, just for the sake of discussion, I am I have found it. I have discussing how do we find the coordinates of all the vertices. Okay. Now, what is PQ? What is PR? PR is obviously, since PR and the diagonals PR and the QS diagonals QS are bisecting each other at the origin O. So obviously PR will be 2 times PO. Now what is PO? PO, the point P is lying on the x-axis. So the distance of the PO is nothing but the distance of the point P from the origin, which will be, so PO will be absolute value of the abscissa of the point P, that is modulus of x1. So modulus of x1 is the will be so 2 times the modulus of x1 will be the length of the diagonals PR. Okay, and what will be QS? QS will be similarly, QS is nothing but 2 times OQ. Since the diagonal QS is being bisected at the origin O, then we must have QS is 2 times QO. Now what is OQ? OQ, Q is the point, is the vertex lying on the y-axis. So the distance OQ is the distance of the point of the vertex Q from the origin. So obviously its distance will be modulus of the ordinate of the point Q, that is modulus of y2, mod of y2. Modulus of y2. Okay. Now remember that since I have considered that in the case 1 the diagonals are lying on the x-axis and the y-axis, and specifically I have considered the diagonal PR is lying on the x-axis and the diagonal QS is lying on the y-axis, this will imply that obviously we must have y1 equals to y1 will be equals to 0, and also x2 will be equals to 0. So based on the coordinates of the points of the vertices, adjacent vertices P and Q, you have to judge whether the diagonals are lying on the coordinate axis or it is just parallel to the x-axis and y-axis, which I will discuss in case 2. So if you see, if the coordinates of the point P and Q are given such that y1 is 0 and x2 is 0, then you will then we can say that the diagonals of the rhombus are lying on the x-axis and y-axis. Okay. So now what will be the area of the triangle? So what will be the area of the rhombus PQRS? This will be half. What is PR? PR was 2 times modulus of x1 and QS was 2 times modulus of y2. So we get area of the rhombus PQRS equals to 2 times product of the absolute value of x1 and the absolute value of y1. This can be rewritten as 2 into absolute value of x1 multiplied by y1. x1 multiplied by y2. x1 multiplied by y2. So this will be the area of the rhombus in the special case where we see from the given coordinates of the point P and Q that the diagonals are lying on the x-axis and y-axis. Okay, now let's consider the case 2 where uh, the diagonals PQ and PR and QS are not lying on the coordinate axis but they are parallel to the coordinate axis. Let's say I'm considering so let's say this is the point P and let's say this is the point Q. So I'm considering so the diagonal one diagonal will be PR. So I'm considering the diagonal PR to be parallel to y-axis. So it will be something like this. The point R will be somewhere like this, where obviously the diagonal PR, this line segment, is parallel to the y-axis. And so the coordinates of the point P is given as x1 comma y1 and the coordinates of the point Q is given as x2 comma y2. So then the fourth vertex R obviously will be such that not R but S, the fourth vertex S will be such that the diagonal QS should be parallel to x-axis. Since I have considered one diagonal PR to be parallel to y-axis, the other diagonal QS has to be parallel to x-axis. So let's say this be this is the vertex S. Okay, so the rhombus is PQ, PQR. So this is the roughly the rhombus. Okay, so now definitely the coordinates of the points P and Q will be such that they are the diagonals formed by the rhombus form, the diagonals of the rhombus will be parallel to the coordinate axis, and specifically I have considered, just for the sake of discussion, the diagonal PR is parallel to y-axis and the diagonal QS is parallel to x-axis. Then what will be the coordinates of the other two vertices R and S? Obviously, PR, the line segment PR is parallel to y-axis. Then the abscissa of the point R will be same as the abscissa of point P, since they lie on the line or line segment PR, which is parallel to y-axis. Now, what will be the ordinate of the point R? Now, okay. How do we? Okay. Okay. How do we know? Okay. So can we find? Is it possible to find? So the diagonals. Let's say the diagonals PR and QS are intersecting at the point. Let's say we cannot consider O because O is used to represent the origin of the coordinate axis. Let's say the diagonals are intersecting at the point T. Can we find the coordinates of the point T? Yes, we can. How? The point T is obviously lying on the line segment PR, and so its abscissa of point P will be same as the abscissa of point P and R. So the abscissa will be x1. What about the ordinate of the point T? Ordinate of the point T, actually it will be uh, the ordinate of the point T will be the ordinate of the point Q, because the point T is also lying on the diagonal QS and the diagonal QS is parallel to x-axis. So the ordinate of the point T and the ordinate of the point Q and S will be same. So the ordinate of the point T will be y2. y2. Okay. Now also what will be the coordinates of the point S? Obviously, the ordinate of the point S will be y2, and we have to know its abscissa. Now, first, let's try to find what will be the ordinate of the point R. Now, obviously, definitely the point R has to be the image of the point, the vertex R has to be the image of the vertex P in the diagonal QS, in the diagonal QS, okay, which is parallel to x-axis. The diagonal QS is parallel to x-axis, and the vertices P and R are images of each other in the diagonal QS. So if I know the coordinates of the point P as x1, y1, what will be the ordinate of the point R? Obviously, the point R will be at the same distance from the point T. The vertices P and R, they will be both equidistant from the point T. Okay. So actually, mathematically, the correct way of writing the ordinate will be, so what is the distance? So okay, so what is the distance between the vertices P and R from the point T? The distance of the point P, since we know the coordinates of the point P and T, the distance PT, that is the distance between the points P and T, will be the absolute value of the difference of their ordinates. Since PT is a line segment parallel to y-axis, PT will be absolute value of the difference of the ordinates of point P and T. So mod of y1 minus y2. So this is the distance. Modulus of y1 minus y2 will be the distance of the points P and R from the point T. Now, what exactly will be the ordinate of the point R? Now, so um, mm, mm, it will be if it so what will be the exactly the value of the ordinate of point R? Y2. Now it will depend actually whether uh, the point R, vertex R, is below the diagonal QS, or it is above the diagonal QS. The way I have drawn the diagram, you can see that the diagonal R, the vertex R, is below the diagonal QS. So in this case, as per this diagram, the ordinate of the point R will be y2. Since the point R is below the diagonal QS, its ordinate will be, and we know that, so its ordinate will be y2. Its ordinate will be it's below. Yes, its ordinate will be y2 minus absolute value of y1 minus y2. Now, depending on the coordinates of the point P and Q, you have to appropriately draw the rhombus, and you will after drawing the rhombus, you can easily figure it out whether the vertex R is above the diagonal QS or below the diagonal QS. The way I have drawn the diagram, in this diagram, the vertex R is below the diagonal QS. So, and we know that the ordinate of point T is y2, and the distance of the point R from the point T is absolute value of y1 minus y2. So obviously, the ordinate of the point R will be, since R is below the diagonal QS, its ordinate will be y2 minus absolute value of y1 minus y2. Now, if the vertex R would have been above the diagonal QS, then the ordinate would have been uh, y2 plus absolute value of y1 minus y2. Okay. Now, what will be the abscissa of the point S? Abscissa of the point S, again the same concept. It will depend whether the vertex S is to the left hand side of the diagonal PR or it is to the right hand side of the diagonal PR. We know that the vertices S and R are equidistant from the point T. So what is QT? What is QT? That is the distance of the point vertex Q from the point of intersection of the diagonal, which is T. This will be absolute value of x1 minus x2. Since the points Q and T are lying on the line segment which is parallel to x-axis, then the distance between the point Q and T will be the absolute value of the difference of the abscissa of the point Q and T. Okay. So then, the vertices S and Q are both equidistant from the point T, and the distance is absolute value of x1 minus x2. So then, what will be the ordinate of the point S is y2. What will be its abscissa? The abscissa of the point S will be, since in this diagram the point vertex S is to the left hand side of the diagonal PR or to the left hand side of the point T, its abscissa will be x1 minus absolute value of x1 minus x2. If the vertex if the vertex XS would have been to the right hand side of the point T, then its abscissa would have been x1 plus modulus of x1 minus x2. So we have found the coordinates of all the vertices. Now obviously, so now what will be the area of the rhombus PQRS? Formula is half the product of the diagonals, length of the diagonals, which is PR, half PR multiplied by QS. This is half multiplied by what is PR. Now what will be PR? Okay, PR. Okay, so PR, what is PR? PR is nothing but 2 times PT, because T is the point of intersection of the diagonals, and we know in a rhombus the diagonals bisect each other. PR is 2 times PT, and what is PT? So 2 times PT, and what is PT? PT is modulus of y1 minus y2. Modulus of y1 minus y2. Okay, and what is multiplied by QS? What is QS? What will be QS? QS will be 2 times QT. So this is 2 times QT was modulus of x1 minus x2. So QS is 2 times modulus of x1 minus x2. So then the area of the rhombus becomes 2 times modulus of x1 minus x2 multiplied by modulus of y1 minus y2. This can be rewritten as 2 times modulus of x1 minus y2, x1 minus x2 multiplied by y1 minus y2. This will be the area of the rhombus. Now there is absolutely no necessary to remember this formula, because it will all depend on the coordinates of the point P and Q. Assuming that the coordinates of the point P and Q will be such that the diagonals, since they are assuming that the diagonals of the rhombus are parallel to the x-axis and y-axis. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now, if you think if you need any example problems based on this concept for to solve, then please do let me know in the comment section. I will highly appreciate that, and then I will make a video where I will solve example problems based on this concept. That is, how to find the area of a rhombus whose diagonals are along the coordinate axis. That is, the diagonals could lie on the coordinate axis, or even they could be parallel to the coordinate axis, and two adjacent vertices are given. So I'm ending the video here. Thanks for watching, and until the next video, take care and bye.